so let's start the second segment. So in this one, we are going to talk about two different algorithms which are used for image segmentation. And the high level idea is to use some kind of threshold to determine like whether this is a segment or this is important segment or this is not important segment. And in this case, we are actually targeting at a very specific kind of segmentation, which is called, like you can say, binary segmentation, where we're just trying to differentiate between foreground pixels and background pixels. All right. So the two different algorithms we have, the first one is binarization, the second is also algorithm. And I think the fifth programming assignment you have that will ask you to implement this algorithm. So please pay close attention to this. Okay. So let's start with binarization. The idea here is, given an image, we just want to say that whether this pixel is foreground or whether this pixel is background. Okay? And we just want to convert it to a binary image. And given an image like this on the left, if we have to perform image binarization, this is like something which is going to be the output. Now you might say that, okay, I mean, why that is useful, but if you think about this, in this image, whatever inference you can make or whatever visual perception you can actually do, I mean, there are a lot of things actually happening. I mean, there are three individuals, right? And we can see a lot of details. We can see the eyes, we can see the specs here, like the gestures they are making, the clothing, everything, right? So even after binarization, I mean, most of that information is preserved. Okay, but again, this is like a lot of less information as compared to this. And there can be a lot of applications of this kind of image binarization. And of course, there's some loss of information as well. For example, like in this image, we are not clear like what was the clothing color, but for some application, it might not be necessary. So the simple solution is, what you do, you actually just set a threshold. Okay, and you say that if the intensity of a pixel location is actually less than this threshold, you say it's a background, and if it's not, then you say it's a foreground. It's that simple, and that will give you like a binary image. But the question is, how are you going to determine this kind of threshold? So for sure, like you cannot come up with a universal threshold, right? Because the threshold is going to vary a lot from images to images. And the reason is like different lighting conditions and a lot of variations you have in your images. So, and that's a difficulty, because even for this image, I mean, on the right, you can see like this is a perfect image. Most of the information is preserved. But to be able to do that, you need like that threshold which was able to do that. Not all thresholds will give you results like this. Okay, so that's the challenge of image binarization. And there are different techniques you can use. And I think some of these you might have seen in your mobile phones as well, when you take images and you try to adjust like the brightness of your images, right? So your app might be showing you some kind of histogram, like what kind of variations you have, the intensity variations you have in your images. And then you might have seen when you scroll around those axes, it might be adjusting the colors and making your picture look beautiful. So again, those are some other applications, but it's like somewhat relevant. Now, the idea is, we have talked about histogram, right? So in your image, if you try to plot histogram of your pixel intensities, let's say you start from, so this x-axis is giving you like all the possible values your pixels can have. So let's say starting from 0 on the left, going all the way up to 255 on your right. And the y-axis is just giving you the count of number of pixels you have for each intensity. Okay, so this plot here, let's say this shows this kind of histogram for the image I showed you earlier. Now you can clearly see that this set of pixels here, okay, so there's a peak over here, belongs to like a group of pixels which are actually darker because it's closer to 0, right? And then you have this dip, And these kind of pixels are actually again grouped together, and they are the brighter pixels. And you can clearly see that these two peaks are actually divided by this kind of valley here. And if you have to divide like foreground and background pixels, you can just set your threshold at this value. Okay, and this is going to be your threshold. And wherever you cut this, so whatever value you have in your x-axis, you can use that as a threshold, and then you can perform the binarization. And of course, that sounds pretty easy, but in reality, what will happen is you will never get like a perfect histogram like this. There will be a lot of variations. But in case you have this kind of histogram, you know what to do. Okay, so that's the threshold.